Good morning or good afternoon. We are on 7.03 geometry today, and I know you guys are going to be excited, but we are talking about parallelogram proofs. And the crowd goes wild. So happy to be doing some proofs, as I'm sure you are too. So for parallelogram proofs, we're going to talk about how to prove a quad is a parallelogram and also what to conclude when given a parallelogram. So first, we're going to start with to prove a quad is a parallelogram, and you're allowed to use that symbol for parallelogram. Use the following theorems. All right, so first, and this one is used a lot, is if a quad has both pairs, I'm going to shorten them up a little bit, if both pairs of opposite sides are parallel, then the quad is a parallelogram. If both pairs of opposite sides are congruent, then the quad is a parallelogram. So we know that there's 5 things that we can conclude from giving a parallelogram. Opposite sides parallel, opposite sides congruent. So those two are going to be used a lot. Those ones are some of the most common ones. Next, if the diagonals bisect each other. Now this one doesn't come up as often. Occasionally it does, but not as common. Then the quad is a parallelogram. If both pairs of opposite angles are congruent, the quad is a parallelogram. If one angle is supplementary to both of its consecutive angles, then it's a parallelogram. And the last one, so that's our 5 things we can conclude. And this one is not something we've concluded before, but really important and also used a lot. If one pair, not 2, but one pair of opposite sides are both parallel and congruent, I don't know why I didn't do the symbol for parallel, then the quad is a parallelogram. So these 3 are used most often. And the rest you'll see occasionally, but those are really, really the ones we tend to find first. So if both pairs of opposite sides are parallel or congruent, or if one pair of sides is both parallel and congruent, then we can get that quad to be a parallelogram. All right, so we're going to start by proving a theorem. And remember our golden rule when proving theorems: you cannot use the theorem in your proof. So if a quad has both pairs of opposite sides congruent, then it's a parallelogram. All right, so remember with the theorem, the if part, so if a quad has both pairs of opposite sides are congruent, that's our given, and then our prove is the then part, so we're proving it's a parallelogram. I'm going to give you a picture to go along with this one. So let's call this A, B, C, D. I'm going to draw in diagonal AC. I'll label some of these angles for you too. All right, so our given we said is our if part of our conditional statement. So quad has both pairs of opposite sides congruent. So looking at our picture, we'd have one pair would be segment AD congruent to segment BC. The other pair, they're not all equal, so I need to mark those with 2 tick marks, would be segment AB congruent to segment DC. And I'm trying to prove that ABCD is a parallelogram. And we're going to do that in a 2-column proof. So we'll start with our givens, of course. And we've already marked those on our picture. So now we kind of have to look and make a plan. All right, so not a whole lot I can conclude directly from each of those givens, from them being congruent, but I'm trying to get this to be a parallelogram, and we know by definition of a parallelogram that both pairs of opposite sides are parallel. So if I can get both pairs of opposite sides to be parallel, then I can get this to be a parallelogram. Well, how could I do that? Well, looking at this, I see 2 triangles. And it looks like I have 2 pairs of sides that are congruent. Oh, and they share this middle side. So I could get these 2 triangles to be congruent. All right, so let's kind of go with that and see where that takes us. So now I've got segment AC is congruent to segment AC. That's my reflexive property. So now I have a side, a side, a side. So I can get those 2 triangles congruent by side, side, side. And remember, they have to be congruent, not equal. And you have to have 3 pairs of congruent statements. Here, remember, make sure you match up your letters appropriately. So A, B, C. So I went 2 marks, then 1 mark. So over here, I'd have to go 2 marks and then 1 mark. So that one would be C, D, A. And I got those congruent. Anytime it's 2 congruent triangles, it's got to be one of our 5 reasons on this side. All right, so once I know that, if I'm trying to get these opposite sides to be parallel to each other, I need to get either all interior angles congruent, all exterior angles congruent, corresponding angles congruent. So here I do notice that I have that Z. So what's true about angle 1 and angle 2? Well, are they part of the same, of 2 congruent triangles? Yes. And are they corresponding? Do they match up? Well, 2 is between 2 marks and the X, and 1's between 2 marks and the X. So they do. So we know then that angle 1 is congruent to angle 2 because they're a part of congruent triangles, and corresponding parts of congruent triangles are congruent. And before I go on to 5, I've got also 2 corresponding angles, 3 and 4. So again, make sure they match up. So 4 is between 1 mark and the X, 3 is between 1 mark and the X. So those also are going to be congruent because they're corresponding parts of congruent triangles. All right, so now I have all interior angles congruent, which means the lines that are forming those all interior angles must be parallel to each other. So now I can say that segment AB is parallel to segment CD. And on the other side as well, I can say segment AD is parallel to segment BC. And the reason would be if all interior angles are congruent, which we just got them to be, then the lines are parallel. So the lines that form them would be parallel. Now that I've gotten two pairs of opposite sides parallel, I can say that ABCD is a parallelogram because if both pairs of opposite sides are parallel, then the quad is a parallelogram. So I've proven something is a parallelogram by definition of a parallelogram, that both pairs of opposite sides are parallel. And I've also proved this theorem that if a quad has both pairs of opposite sides congruent, then it's also a parallelogram. So I can't use that exact theorem, but I can use something that comes before that, so that definition. All right, let's go the other direction now. If we are given a parallelogram. So before, we were trying to prove a parallelogram. So here we can conclude our 5 properties of a parallelogram. So number 1, we can conclude that opposite sides are congruent. So these are the 5 things we can conclude about a parallelogram. Really important to know these 5 really well. Opposite sides are parallel, because not only are these things true about a parallelogram, they're also true about a rectangle, a rhombus, a square. Opposite angles are congruent. Consecutive angles are sup. And then number 5, the diagonals bisect each other. So take a moment to really make sure you know these. Maybe quiz yourself right now, pause the video, see if you know these 5 properties. So flip over your paper and then say, what are the 5 properties? Opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles sup, diagonals bisect each other. All right, now let's do a proof using these. So we've got, this will be number 2. Given AECF is a parallelogram and segment FD is congruent to segment BE, prove ABCD is a parallelogram. So this one actually has both in here, using a parallelogram and proving a parallelogram. Got A, B, E, C, D, F. And I'll set up my proof. Write out my givens, and of course, mark my picture. Okay, so I've got segment FD is over here, is congruent to segment BE, and AECF, so this big parallelogram, the outside one, we know is a parallelogram. Once I'm given a parallelogram, I have 5 different conclusions that I could possibly make. It's kind of like with your parallel lines. You've got lots of conclusions to make. So if you're stuck, you just start concluding all of them and hope that one of those is going to help you, and it definitely will. And then you're at least going to get points for that one that's going to help you. We're not going to just start concluding. We were going to do it a little bit more focused. So let's kind of make our plan. So we're trying to get A, B, C, D. So we're trying to get A, B, C, D to be, let's use some colors here. A, B, C, D, this pink one, I want to be a parallelogram. All right, so to get something to be a parallelogram, I can get opposite sides congruent, opposite sides parallel, the angles congruent. I can get one pair of sides to be both congruent and parallel, consecutive angles sup. So far I have these two sides congruent, and I know this original is a parallelogram. All right, so one thing I would know here is that opposite sides of a parallelogram are parallel. So if ABE is parallel to FDC, then just part of that line would also be parallel. So I can definitely get one pair of sides to be parallel to each other. All right, I can also get opposite sides congruent. So I know that segment AE will be congruent to segment FC. Is something popping out at you guys? No. Hopefully, maybe you're looking at this saying, oh, well, if I've got the whole and a part, maybe we could do segment subtraction to get these two sides to be congruent to each other. If I do that, then I'll have one pair of sides both congruent and parallel. So now let's try and write this out. So I've got segment ABE is parallel to segment FDC. And that's because in a parallelogram, opposite sides are parallel. And again, because that whole segment is parallel up here, ABE, we know that AB is also parallel to just DC because they're a part of those two segments. All right, now we know that segment AE, we said, is congruent to segment FC because in a parallelogram, opposite sides are congruent. All right, so now let's focus on trying to get AB, segment AB, congruent to segment DC. So if I know I'm going to be using segment subtraction, I know I'm going to need two sets of equals. So I'm going to start off by getting those to be equal. So I want the wholes to be equal, so that's AE equals FC, and I want these parts that I'm going to be subtracting to be equal. So FD equals BE. And if that didn't pop out at you right away, you might think about it in terms of numbers. So like here, maybe this is 10 and this part is 2. So then if this is 10, this is 10. If this is 2, this is 2. 10 minus 2 gives you 8. 10 minus 2 gives you 8. So that tells us two things. We can do subtraction and that we can get those two parts to be equal if we have the wholes equal and another part. So to change to equality, we use def of congruency. And now I can start by doing my segment subtraction. So AE minus BE will equal AB. And FC minus FD equals DC. And if you think you've got it from here, which I think probably most of you could take it, pause the video, try to finish this completely on your own. All right, so this one should be segment subtraction postulate. And I'll go a little faster since I think a lot of you guys have it now. So then I can do my subtraction property of equality. So take these two sets of equals right here in step 4. So AE minus BE equals FC minus FD. And that is subtraction. Remember, you can't abbreviate that one. Property of equality. Now I can take AB and sub it in everywhere I see this AE minus BE. And I can take DC and sub it in for FC minus FD. And that's our substitution. And we want opposite sides to be congruent, so I'm just going to switch these back to congruency by def of congruency. And now, right here, I have a pair of sides congruent, in ABCD. And here I have the pair of sides parallel to each other. So now I can say that ABCD is a parallelogram, because if both pairs, not both pairs, one pair of sides is both parallel and congruent, then the quad is a parallelogram. All right, so again, you should be able to do the proof given a parallelogram. You've got 5 conclusions, and prove a parallelogram as well. So I want you guys, I'm going to give you 2 different proofs to kind of go through and try on your own. And here's your given, segment FE congruent to segment CE. Prove that BEDF is a parallelogram. So again, both directions here. Here's your picture. D, C, E, A. Got segment AC, the diagonal drawn in. And then you've got DF, segment DE, and then you've got BE and BF. This one's F right here. Obviously not drawn to scale. So take a minute here, pause the video. I want you to try to do this one completely on your own. Okay, go ahead and try it. All right, so you know ABCD is a parallelogram, so if it helps, you could trace that in a color. You've got segment AF is congruent to segment CE, and we're trying to get BEDF, which my drawing is quite awful. That's going to be a parallelogram there. All right, start with your givens. And what I'm going to do here is I'm just going to write out the left-hand side, the statements, and I'll talk through some of the reasons, but you guys should have all of it written out, but I want you guys to really be doing this completely on your own at this point, or at least trying it with the little hints. All right, so ABCD is a parallelogram, so that means we have 5 different conclusions. I want to get, so what you could start by doing is just kind of marking everything up. So I've got opposite sides. Oh, I need 3 here and 2 here because I already used 1 on AF. Oh, you can't see. AF and segment EC. And I want to get this to be a parallelogram, which I might just move that over a little bit to make it look a little more like a parallelogram. Okay, and I'm confused with those extra lines. Okay, so hopefully you concluded everything, marked your picture. Now I would say here, get my segment DC is congruent to segment AB, segment AD is congruent to segment BC. My reason there would be in a parallelogram, opposite sides are congruent. Also can get my opposite sides to be parallel to each other. So DC, segment DC is parallel to segment AB, and segment AD is parallel to segment BC. And your reason, in a parallelogram, opposite sides are parallel to each other. All right, once you get to there, then we could say that you can get your alternate interior angles congruent. So you could call those like DAC, or if you want to put numbers in there, that's fine too. Since I don't have the numbers, we might have different. I'm going to just use angle DAC congruent to angle BCA. DAC, so that's your alternate interior angles, BCA. Also, we've got angle CAB congruent to angle DCA. And the reason there would be if two lines are parallel, alternate interior angles are congruent. So that gives us CAB. Knowing that, now I could get these two triangles to be congruent. So I have triangle DCE. So I have a side here. I have a side here. Let me give you a different color. A side here. It's kind of close to the pink, sorry. A side here, and now I have you can't see. A side here, and an angle here. So I can get this triangle up here congruent to this triangle down here where I have that side, a side here, and an angle. So I can say triangle DCE is congruent to triangle BAF, and that would be by side angle side. Once I have those triangles congruent, I know that their parts are going to be congruent, so I can get these two sides to be congruent by CPCTC. Now, well, I'm just going to do that now. So that gives us segment FB congruent to segment DE by CPCTC. That gives me one pair of sides that's congruent now. I need either that pair of sides to be parallel, or I need another pair of sides to be congruent. Well, we got these triangles over here. Let's see what color I've got. We have these sides congruent. We have these sides congruent, which was given to us. And now we have those alternate interior angles congruent. So we can also get these blue triangles to be congruent by side angle side again. Side angle side. So I could say that triangle CBE is congruent to triangle ADF, and make sure you match up your letters correctly. So C with A, B with D, E with F. And that would again be by side angle side, and then I can get segment DF congruent to segment EB by CPCTC. And then lastly, I can say that BEDF is a parallelogram. And again, the reason would be if both pairs of opposite sides are congruent, then the quad is a parallelogram. And so if you had trouble with that one, I would recommend going back, try redoing it now that you kind of see some of the things that you should be looking for there, and see if you can do it completely on your own. All right, and we're going to do one more. So this is number 4. Given A, B, C, D, and D, E, B, F are parallelograms. Prove segment AX congruent to segment CY. And there's a couple different ways of doing this proof. So I want you guys to take your time and try to figure out a way that makes sense to you. So I'm going to draw in the diagonal here. And A, B, C, D, we know is a parallelogram, and D, E, B, F. So we've got this is E, this point right here is Y, this is X, this is F, again, not drawn to scale. That's a straight line there. This is why they also tell you that BYE is a segment and DXF is a full segment. And segment AC as well. Statements, reasons. Write out your givens. Start marking up your picture. Since you're given two different parallelograms, then I guess actually you don't need to state these since we already know they're parallelograms. Start figuring out what you can conclude, maybe make a plan for that, and then try writing it out. So pause the video here. All right, so again, you might want to trace these. So DEBF, we know that one is a parallelogram, and we know Mrs. Brzozowski is not very good at drawing these pictures, which is why I like to hand them out usually. And then ABCD, this green is also a parallelogram. So we've got two parallelograms there. We want to prove that AX over here is congruent to CY. All right, so you could work your way backwards and you might think, okay, are those two a part of two different triangles? And say, oh, yes, they are. Well, they are part of two different triangles, both of them. So maybe choose a pair and think, well, which of those could we get maybe to be congruent? And that might become more apparent after you've marked your picture. So if you haven't already, please pause the video, mark your picture, draw some conclusions, see if you can get maybe two triangles that these two are part of, and then get those to be congruent. All right, so I've got these two sides are congruent. Now that makes me think that I might like these triangles here. So because the other triangles up here, those don't have a full side of the parallelogram. So I know it's hard to see, there's so many colors here. So far I only have those sides, but that's making me think I might like get these two triangles to be congruent. So right now, and a goal can always change, is I'm thinking to get triangle ADX congruent to triangle CBY. But I don't know how yet. So let's keep going. So I've got a pair of congruent sides. Over here, I do know that they're parallel as well. And trace my Z, find my alt interior angles. So I've got an angle here and here. And let's call those 1 and 2. So that gives me an angle, and I still need something else. So I would say, since I'm working on trying to get those two triangles to be congruent, I'm going to go to my other parallelogram before I finish with the big one, because I haven't used that yet. So this pink parallelogram. Now the pink parallelogram I know has opposite sides congruent. That doesn't appear to help me with those purple triangles though. I know that the opposite sides in a parallelogram are parallel, so does that help me at all? So maybe I look for my Z. So I say, okay, I don't really have a Z here because there's no diagonal drawn in. Oh, but there's this piece here. So I could get these angles to be congruent. Oh, what about, not only could I get these two to be congruent, but I could get, and this one is a little bit harder to see because it doesn't come up as often, this angle and this angle, those are alternate exterior angles. So let's call those 3 and 4. I'm going to move my Y so I can call that 4. We'll call that Y. The point is Y right here. So I could get these two, 3 and 4, to be congruent, by looking at those parallel lines from the pink parallelogram, and those are alternate exterior angles. And now I have angle, angle, side, angle, angle, side. So I can get those two triangles to be congruent. All right, so if you write it out, again, I'll just write out the statement. So segment AD parallel to segment BC, segment EB parallel to segment DF. In a parallelogram, opposite sides are parallel. Actually, you know what? I don't want you guys to just copy this. So I'm going to have you guys write it out now that we've kind of discussed how to do it. And if you haven't already, I'll just kind of go through again one more time what to do here. Get your opposite sides to be congruent from your green parallelogram, because in a parallelogram, opposite sides are congruent. Get your opposite sides, make sure you state their parallel first before, like I started to do here, before you get your alternate interior angles congruent. So state segment AD parallel to segment BC. In a parallelogram, opposite sides are parallel. Then you can get angle 1 congruent to angle 2, because if two lines are parallel, then alternate interior angles are congruent. Then we could state that that gives me a pair of sides and my angles. Now I need to get these other angles here. So then you need to state, like I did here, that segment EB is parallel to segment DF, because in a parallelogram, opposite sides are parallel. Again, you can put those in the same step is fine, or two different steps. Then you would say angle 3 is congruent to angle 4. The reason for that would be in a parallel, or if lines are parallel, alternate exterior angles are congruent. And then you could say that triangle ADX is congruent to triangle CBY by angle, angle, side. And then get segment AX congruent to segment CY by CPCTC. All right. So if you have any questions on any of those proofs, make sure you let me know. And I hope you guys are all doing well. I hope to see you soon. Pie out.